In this lesson, we're going to look at using formulas. Now, we have formulas from geometry. For example, the area of a trapezoid is 1/2 base 1 plus base 2 times height. And one of the important things for us to do in mathematics is to be able to start with some formulas, get the relevant numbers, and then plug them in to get the values. So let's go ahead and draw a trapezoid, and let's show how we can use that formula. So if this base is 3 units, this base is 5 units, and the height is 2 units, we're going to go ahead and make the substitution. So let's identify what they are. Base 1 we'll say is 3. Base 2 we will say is 5. And the height we will say is 2. So the area is 1/2 B1 plus B2 times H. So the area is 1/2 3 plus 5 times 2. So the area is 1/2 8 times 2. So the area would be 8 square units. Another formula that we've used often is the conversion formula from Fahrenheit to Celsius. So the equation is Celsius equals 5/9 of F minus 32. So if the current temperature, 60 degrees Fahrenheit, what is the equivalent in Celsius? So we can go ahead and we can make a substitution. So we have our formula again, C equals 5/9 of F minus 32. So C equals 5/9 F is 60 minus 32. So C equals 5/9 of 28. And then using a calculator for that, 5/9 of 28 gives us about 15.5 degrees, 15.6 degrees Celsius. One of the most important formulas in science is the relationship between mass and volume yielding density. So we know that density equals mass divided by volume. So we will shortcut that by saying D equals M over V. So in this question, we will say that the mass is 68 grams and the volume is 5 milliliters, and our goal is to find the density. So let's keep track of units this time. That becomes very important in science courses. So again, density is mass divided by volume, which in this case will be 68 grams divided by 5 milliliters. 68 divided by 5, grabbing the calculator, gives us 13.6. And the units of density in this case will be 13.6 grams per milliliter. One of the most important equations in chemistry and physics is the ideal gas law, which tells us PV equals nRT. And it's important for scientists to be able to use this. Now, I don't want to worry too much about units here, but let's go ahead and come up with some values to say P is going to be 202.6 of that unit, which you don't know what that means. N is 0.05 mole. Again, a unit you probably don't know what it means. T, temperature, is 400 Kelvin. Maybe you do know what that means. V is what we're going to look for. So B we don't know. And R is going to be 8.314 joules K inverse mole inverse. And again, don't be too concerned about the units. That's going to become very important for us in science class, but not so important for us here. And our goal is to find v. And you can see from our problem we want to solve for v. The first thing I'm going to do is I'm going to divide both sides by p. And we will say v is n RT divided by p. So plugging in the numbers and not caring too much about units, n is going to be 0.05, r is going to be 8.314, t is going to be 400, and p is going to be 202.6. And when we do all that, we get an answer of 0.821. Significant figures will also be important in science classes. The units happens to be liters, so I will go ahead and I will say that for you. Another important equation that we have is the exponential growth equation, namely y equals ce to the kt. Now this is a little more complicated because we have an exponential, we have an exponent that we have to work with. So if, for example, we're going to say that c is 100, k is 0.2, and t is 25, find y. We can do that, but we've got to be a little more careful here because, again, we're dealing with exponential functions. So in that case, we would say y equals c, 100. E is a constant, a mathematical constant. We'll talk about that in a minute. To the k, 0.2 times t times 25. Most calculators have e on them. If you don't have e on your calculator, e is about 2.718. So what you could do is you could say y equals 100 times 2.718 to the 0.2 times 25 power. 0.2 times 25 is, of course, 5. So you need to use the exponent button on your calculator to say 2.718 or e. I'm going to just use e on mine. To the 5th power. Multiply that by 100. And the answer that I get is 14,841. Now, we're not going to worry about this in math class, but in science class you study something called significant figures. And you want to make sure that the way you round something off is going to be the same in your answer as it was in the question. These basically have maybe 2 significant figures, so the fact is a better answer for this in science class would be 15,000. Although in math class typically we're going to be okay with more precise answers. Let's do one more example. Let's say that z is k times x squared y. And this can be used to represent a form of joint variation. We're going to say z varies jointly as the square of x and y. And we'll talk a little bit about direct and inverse variation later. And then we're going to say find z when k is 3.2, x is 7.3, and y is 1.8. So again, this is the kind of problem you're going to want to use your calculator, so we'll have it handy. Z equals k, 3.2, times x squared, times 7.3 squared, times y, times 1.8. Then grabbing the calculator, 3.2 times 7.3 squared, times 1.8, yields 306.95. Which again in math class is fine. But if you want to think about significant figures, these only give you 2 decimal places of accuracy. So we'll say 310.